Welcome to the session where we're going to be looking at using the ArcGIS Runtime SDK for Java for building applications. So I'm Mark Baird and I'm joined with my colleague Jonathan Lavey, and we're both engineers on the runtime team. So in this session, we're all about getting started with our latest release of the SDK, which is 100.7. And we're going to be talking about writing Java 11, JavaFX desktop applications, which are cross-platform. And we'll introduce you to some of the key concepts and patterns that you'll need to create your own applications. We'll also introduce you to graphics overlays because these are very important to many Java developers. And we'll also cover some of the concepts introducing you to the capabilities of offline maps. Now, there are sessions dedicated to offline maps. This is just an introduction to the session. So if you are interested in more information on offline maps, then I suggest you listen into one of these sessions. And then we'll complete the session by talking about licensing, finally deploying your application so that you can make it go live to market. So in terms of getting started, probably the best place to visit is our developers website. So this is developers.arcgis.com. So I'm going to switch and give you a guided tour of that. So the landing page here is for all of our developer technologies, but if you go into documentation and ArcGIS Runtime SDK for Java, you've got the landing page for our SDK, which gives you lots of marketing information about the capabilities of the SDK. And there's also recordings of previous sessions that we've recorded on the product. Probably of most interest is the guide documentation. So this breaks down into common use cases, descriptions of how to implement key pieces of functionality into your own applications. And then to complement that, we've got a large quantity of sample applications, which are all stored inside GitHub. And what these are sort of small, very focused applications that show you how to implement key use cases in your own applications. And because you can get this code from GitHub and run it in your own apps, you can also copy this information, this code out, and put it into your own applications. It's there to show you best practice for implementing this technology. The API reference is there online, but of course you'll be able to view that inside of your IDE. And we also have a support forum called GeoNet, where you can post questions if you've got any difficulties with using the SDK. It's also worth mentioning we have a toolkit for the Java SDK, which complements the map view and the scene view controls and allows you to add in extra capabilities like north arrows or scale bars. It's completely open source. There's a GitHub repository that shows you the source code for this, so you can modify it for your own requirements. But if you're happy with it as it is, then we have this hosted as compiled binaries inside a Maven repository. So just going back to the slides, the SDK is available in two different ways. So first of all, there is a zip or tarred gunzip file that you can download, and this contains all of the required files for you to manually wire up your SDK for using our libraries. But probably more common these days, we've actually made it available in a Maven repository, and you probably use Gradle or Maven script to inject these capabilities into your own apps. And we've got sample scripts in our website that explain how to bring all this together. So just looking now at Java itself, just want to set the scene here and rewind 18 months just to talk about some things that have happened recently. So around about 2 years ago now, there were news articles appearing online which initially might have looked quite alarming. So there were notices like the end of public updates for the Oracle JDK 8. Oracle are going to be charging for Java from 2019. JavaFX will be removed from the Java JDK. Well, in fact, all of these things came true, but it shouldn't deter you from using the SDK in the spirit of Java apps as we know them. So we're now based on Java 11 and we will be embracing Java 14 in our next release. But just to set the scene, so 100.4 of our release was the last release that we supported in Java 8. And then from 100.5 onwards, we were basing ourselves on Java 11. And as I've already mentioned, for 100.8, we will be supporting Java 14, which will have been out for a couple of weeks after we have released the SDK. So nowadays, you can choose the Java runtime environment that you run your applications in. Previously, we only tested it against the Oracle JDK, but you can now choose the Adopt OpenJDK, which is actually what we use to build the product, OpenJDK, or you can still use the Oracle JDK. We test against each one of those. Now, it is true that JavaFX is no longer part of the JDK. They are available, however, in separate binaries. So they're available from Maven repositories. And this is an active open source code base that is led by Gluon. So it's still being developed. So let's now take a look at some of the key concepts and classes and patterns that you need to be familiar with to write your own runtime application. So we'll just start off by talking about 2D applications. So to write 2D applications, there are two key classes that you need to work with. So first of all, there is a map. Well, we actually call that the ArcGIS map in Java. And what this does is it defines the business data that you're going to be working with inside your applications. So typically that will include a base map. So this is the wallpaper for your application, like OpenStreetMap data, for example. And then on top of that, we will have our operational layers. So this is your business data. So this could be feature services from ArcGIS Server or ArcGIS Online, or you could be consuming OGC compliant data sets. And then to visualize that data, you'll be making use of the JavaFX map view components. And this enables you to visualize and interact by panning and zooming with your data. You just need to programmatically associate the two classes together and you've got a working app. Now, writing 3D applications is very similar. So rather than working with a map and a map view, you'll be working with a scene, the ArcGIS scene, or a scene view. So the scene is the equivalent to a map in 3D. And indeed, it's virtually the same. So it contains a base map and the operational layers for your business data. But because we're working with a 3D visualization here, we have the concept of a surface. So you can see the lumps and bumps that make up a mountain, for example. And then to visualize the data, you will have a scene view JavaFX control in your application that you associate with your scene, and you've got a fully functional 3D application. Now, before we jump into looking at some specific code, it's worth me introducing this state transition diagram that we call the loadable pattern. So this is a pattern that we have all over the SDK, especially when we're working with resources that are slow to respond. So I'm thinking here about network resources, which usually they're quite quick, but sometimes the internet can be slow. So if we just picture a feature service that contains some asset information that you want to store in your application, when I instantiate the class to add one of these into my application, it's in a not loaded state. And then as soon as I start interacting with that, in the background there'll be some HTTP communications going on just to establish that the service is there and what its capabilities are. But whilst this is happening, it will go into a loading state. And then provided all is well and we successfully make a connection to the server, this will go into a loaded state. And these are all events that I can listen into asynchronously off the UI thread. So the key thing is when we're waiting for these resources, we don't want to be blocking the UI thread because that's going to make our applications halt and freeze, and users get frustrated by this. Now, if something goes wrong and you don't manage to make your connection to the service, it'll fall into the failed to load status. So at least you can programmatically deal with the fact that the application has not behaved in the way that you want it to. And all these things are items that we listen into asynchronously. So let's just go and take a look now at some code. So Jonathan, let's go and take a look at some of this in action in an IDE.
Thank you, Mark. So in this first demo, we're going to look at a very simple example of how to use the map view and the ArcGIS map classes to display this very nice looking base map, this terrain base map, and also how to load some data in that's coming from a feature server. So this data here, some geological data that's coming straight from a feature server, and we're going to show you how to display that in your app in one of your maps. So let's dive into it. To begin, we need to satisfy some of the JavaFX requirements. So we're going to create a stack pane and a scene, and we're going to set up our stage. So we're going to give it a title, a height, a width, and eventually show that stage and scene. This is where the interesting parts begin. We're going to use a base map, this terrain base map here, and use that to create our ArcGIS map object. Then, to hold that map, we're going to need a map view, so we're going to instantiate one of those as well. And finally, set that map to our map view. That's all we need to do to display our base map. And now, let's say we have this URL here that represents our data coming straight from a feature server with our geological data, and we want to display that to our map. So what we'll do is we'll create a new service feature table from that URL and use that service feature table to create a new feature layer object. Finally, we're going to take that feature layer and simply add that to our map's list of operational layers, which will cause that data to be shown in our map. And last but not least, all we need to do is set the viewpoint of our map to an area that is similar or in the area of the data that we want to show. And finally, if we start this, we'll be able to see our data load from the feature server and appear on our map.
Excellent, so that looks really good. So I'm wondering what would happen if something went wrong with that application and it couldn't get a hold of that endpoint. So just maybe try to break something here just to see what happens.
Yeah, let's have a quick try. So for example, if we delete part of this URL
that's never going to work, okay.
And have a try in launching that. What we'll see is that the app actually silently fails. The feature layer never actually manages to load because the URL is obviously wrong. So all the users see is this empty map. They don't see the data that they wanted to see. So logically, they will become quite frustrated after a while.
Yeah, so this is where our loadable pattern could come in just to give us some feedback. So let's go and take a look. We've got another code example here just to show how we can listen into some good and bad things in the...
Yeah. Exactly. So in this demo app, we will see pretty much the same setup. So we're going to have our feature layer and feature table set up from this URL here. And we will have that feature layer added to our map. But what we're going to do differently is we're going to add a done loading listener to our feature layer. So as soon as that feature layer object is instantiated, it's going to start that loading process. And by adding this done loading listener, we can specify code that on a new thread will happen asynchronously once our object has actually finished loading, once our feature layer is completely loaded. So what we're going to do is, in this Lambda, we're going to check first whether our feature layer is loaded successfully, and if that's the case, we're going to set the viewpoint asynchronously, so use a small animation of the duration of 4 seconds to pan in towards our area of interest. And if that doesn't work, we're going to show the user a new alert. We're going to show them the load error message of that feature layer to give them a little bit more information about what is going on. So if we were to do the same thing here again, we're going to break this URL, just delete a big chunk of it, and try and start that app up. What we expect to see is a little error. So what we get is no such host is known. So we know our asynchronous code is working great. If we now fix that URL up again and start our app again, we should see that asynchronous code kicking in. We're going to have that nice little zoom animation, and eventually our feature layer will load as expected.
Excellent. Okay, so let's just go and take a look at this code actually, because there's a little vulnerability here which I see happening sometimes in applications. So you'll notice that we are working with a feature layer. So if we just highlight that. And we're actually reading that feature layer in the done loading listener, but that's actually done inside a separate thread. Now, it's possible that the feature layer class instance we have here could be garbage collected, because it could have gone out of, well, it has gone out of scope. So that is actually fair game for the garbage collector to clean it up. So to make this piece of code so that it's really solid and we're not going to get caught out by any unwanted garbage collection, we do need to stop that feature layer from being garbage collected. So you've got a way of doing that, John.
Yeah, we're going to refactor it, and we're going to introduce a field. Well, we cannot perform that right now. So what we're simply going to do is create this into a class member. So I'm just going to head back up here, create a private class member. And now we can use that private class member and be sure that it won't get garbage collected.
Yeah, it won't go out of scope, so that is now a rock solid piece of code, very reliable. Okay, thank you, John. So we just go back to the slides now. So until now, we've been talking about populating the contents of the map class programmatically. So Jonathan was specifying the base map and adding in the operational layers. You don't have to do that, because we have this concept in ArcGIS Online of web maps. So you can have somebody who can pre-author a map, and they can set the base map, and they can set the operational layers and set the way that they're rendered, and all sorts of things to do with how the map is visualized. And of course, these web maps can be visualized inside JavaScript applications or runtime applications. So what we can do is we can actually inflate the contents of the map class with a predefined web map. So what I'm going to do now is just switch over to a web map. So this is a weather map. It's showing lots of rain, as it is raining here quite heavily at the moment. And what I can do is I can take the web map reference for this, and I can put it inside the runtime application to display exactly the same data, which has been nicely authored in ArcGIS Online inside my runtime app. So let's just go and take a look at this.
Thanks, Mark. So here it is. I've got a little demo app open that shows exactly the same web map. And you'll notice it does appear the exact same way as it does in your browser. So let's have a quick look at how we can do this quite simply in a piece of code. We're going to start off with the same thing. We need ourselves a map view to hold our map. But instead of creating this map locally that we're going to show, we're going to create a connection to ArcGIS Online. So we're going to create this portal object, which is going to use this URL for ArcGIS Online. And we can then use that portal object to query web maps that exist within this URL. So what we need to do first, we're going to load this portal and wait for it to load. So we're going to use our add done loading listener. Once that is loaded, we can use the item ID of the web map that we're interested in. This is a publicly shared web map. And we'll use that item ID to create a new portal item from this portal with this ID. Once we have that portal item, once again, it is a loadable object, so we will need to initiate the loading process and add a done loading listener to it. Once we're happy with this and we know that our portal item has loaded, we can use that portal item to create a new ArcGIS map object. And then, as we did before, we'll simply add that map to our map view, and that's all we need to do to show a web map.
Okay, so this is just taking pre-authored maps, which will look exactly the same regardless of whether they're viewed in the ArcGIS platform, whether it's a web app or a JavaScript application or a runtime application even. Okay, so let's just go and have a look at graphics overlays now. So graphics overlays I find are used by lots of Java customers. And if you've not used these before, I would sort of describe them as being used commonly for displaying temporary like redlining data, just some scribbles on your map just to sort of highlight something, or for updating fast updating items. So in this use case, maybe you're listening into a radio feed which is tracking the location of assets that you're interested in, and you want to be able to sort of update the location of those at a very high frequency. You've also got a large number of them. This is not the kind of thing that it's very efficient to store inside a feature service, for example. So graphics overlays, very much like feature layers, can display points, lines, and polygons, and they're rendered in exactly the same way as feature layers. So the symbols and the renderers that you're familiar with can all be used in the graphics overlay. One thing it's worth noting here is that the graphics overlay are actually they're part of the map view or the scene view. And the reason for this is they're not persisted. Graphics are entirely your responsibility as a developer because they're stored in memory. So when you close your application down and restart it, you need to put your graphics overlays back and your graphics back that you're wanting to display. So they're not persisted inside the map or the scene classes. Now, in terms of the draw order, when this is all rendered on the screen, you start off with the base map, and then on top of that, you draw your operational layers. So this is your business data, your ODC, or your feature layers. And then on top of that, we draw the graphics overlays. So to show that in action, I'm going to hand you back now to Jonathan, who's going to show you some fairly simple designs. So we'll just switch over. So I'm just going to hand you over now to Jonathan, who's going to show you a graphics overlay in action.
Right, thank you, Mark. So here's another simple example of how to use our API to display graphics on a graphics overlay. What I've got here is a nice little topographic map of Scotland and a simple little graphic that represents a mountain right in the center here. So let's walk you through how to create one of these. I'm going to start off in a similar way. So we want a map, and we're going to set that to a map view. And here is where we create our graphics overlay, which is going to hold our graphic. We're going to take that graphics overlay and we're going to add it to our map views list of graphics overlays. And then in this step, we're going to use a little image. We're going to use a PNG of a little mountain to create a Java image. And then use that image object to create a picture marker symbol. And this is the symbol that's going to represent our graphics. Now we want to define where on our map this graphic is going to sit. So we're going to define a new point with some longitude and a latitude and a spatial reference to use as a guide for where our graphic should be located. And then we're going to create this new graphic object using this point and our picture marker symbol. And then we're finally just going to take that graphic object and add it to our graphic overlays list of graphics. And as a result, what we get is this nice little graphic displayed on our topographic base map. Now, this is a very simple example of how to create one graphic. However, if we're trying to display a large amount of graphics, then defining the symbol for each of these graphics may not be the best way to go forward, because we'll be having a lot of graphics and a lot of symbols, meaning we're going to put a lot of strain on our graphic card's resources. So in the second demo, we're going to have a quick look as to how to use a renderer to show many graphics at the same time with only specifying our graphic resource once, as well as how to use our labeling definition to show these dynamically updating labels that show some information. So for the sake of this example, let's assume I have a large amount of information that's coming, say, from a GPS device if I've been out hiking. And I want to show all the mountains that I've been on and show some of information on them using graphics. So let's have a quick look. I'm going to start the same way. We're going to create a graphics overlay and add that to our map views list of graphics overlays. We're going to use that little mountain image to create a picture marker symbol once again. But this is where things are getting slightly different. So instead of applying this picture marker symbol to each of our graphics, we're going to use that picture marker symbol to create a new simple renderer. And this renderer we're going to set to our graphics overlay. And now the graphics overlay would know to use this particular symbol with the renderer for any graphics that we're going to add to that graphics overlay. So let's add a simple graphics. Once again, we're going to specify a point, the longitude and the latitude and the spatial reference. And we're also going to give this graphic some attributes. So we're going to give it a key value pair with a key of info and some information onto that mountain. And then we're going to use our point and our attributes to create that new graphic. Then we simply add that graphic to our graphics overlay like we did before, but the renderer will take care of using the image for us. So you will notice in this case we haven't specified our picture marker symbol at all because the renderer is taking care of that for us. Let's have a quick look at how to set up the labeling definition. We're going to have to specify that as a string, as a JSON string, and we're going to specify which label expression our labeling engine should look for. So in this case, it's going to look for that key info, and the value of that is going to hold the information that we're going to display. Then we're going to define the label placement, a symbol, a color, a font, and a font type. Finally, we're just going to use this JSON to create our actual label definition object, add that to our graphic overlays list of label definitions, and set the labels to be enabled. After that, any graphics that has an attribute with the key of info will be displayed with its information as a label. Now, going back to the use case that I've described, let's assume we have a large amount of graphics. We're going to grab this list that contains a large amount of graphics, which should come, for example, from your GPS device. And some of these graphics have information in them, but none of them will have a particular image or a particular symbol that's going to be used to represent them. That's what the renderer is going to do for us. And then all we have to do is take our graphics overlay, access the list of graphics, and add all of our graphics at once. And then we should get this nice result that we've seen before. The renderer is doing all the work for us and choosing which symbols to use, and the text is being updated on the fly as we zoom and pan around. And that's back to you, Mark.
Thank you. So yeah, just to summarize, the graphics overlays are capable of updating many thousands of graphics at a very high frequency. So I mean, Munros don't move around, but if you were tracking something like taxis or vehicles that you wanted to update, you could have a very high frequency updating display. Okay, so let's just talk now briefly about offline data. So this is one of the major advantages of working with runtime applications, is we have the ability to be able to work with data when you don't have any network connection. So at a high level, we support two patterns when we're working with this. So the first of which is we call the services pattern. So this is where your data resides in ArcGIS Server or maybe ArcGIS Online. And the workflow is such that you will use your application to define an area where you want to work offline, where you won't have any network connection, and you'll use that extent to make a request to your services, your map, so that you can request the server to create a package that you can download and sideload onto your device. You can then read that data when you don't have any network connection, and you can also edit the data. And then when you're back in an area of network connectivity, maybe at the end of the day, you can synchronize any changes you've made to that data back up to your feature services. And this is a two-way process. So not only are you uploading changes that you have made, you'll also be downloading changes that anybody else has made in the area that you've taken offline. So the end result is an up-to-date package of data that's ready for doing more data collection the following day. Now, the second pattern that we support is the desktop pattern. So this is where you can create a package of data using ArcGIS Pro that you can sideload onto your device for read-only purposes. So this is not for editing workflows, this is just for data which you would work with just to visualize whilst you're out in the field. There are many sessions you can look up that explain these workflows in a lot more detail, but this hopefully will give you a picture of the capabilities that are available. So let's move on now to licensing deployment so we can make our applications go live to market. So when you're using Runtime, you will be using one of the 4 different license levels according to the level of the functionality that you're using inside your application. And there are 4 levels, so there's Light, Basic, Standard, and Advanced. Light being a free deployment and increasing levels of cost associated with Basic, Standard, and Advanced. Now, in this session, I'm not going to go through specifically what those areas of functionality are. There's a web link here which you can go to find that. What I want to concentrate on in this session is technically how you license your applications in your code. Now, there are 2 ways of licensing a runtime application. The first of which is what we call named user. So this is when you are a user of ArcGIS Online or Portal for ArcGIS. And to license your application, you just simply log in to your portal, and this will unlock the capabilities of Runtime. Now, we recognize that not everybody is a user of the ArcGIS platform. So in this case, you can actually license your application by putting a license key into your application. And these license keys are available from customer services or your local distributor. So let's just take a look at the code associated with this. I'll look at the license key to start with because this is the easiest one to show. So you have your license key packs that you have got from customer service, and all you need to do is using the ArcGIS Runtime Environment Set License method. You just pass in the string that you've got, and that will license your application. You should be aiming to do this very early in the life cycle of your application. So you can see here in my JavaFX app, I'm actually calling the setLicense method as the first piece of code inside my main class. And this is before I've even launched the JavaFX application. So very straightforward. So named user licensing is when we need to log into our portal to unlock the capabilities of Runtime. Now, I'm demonstrating this with code, which I have to admit is very bad practice, but it's a very good way of explaining the processes that we're going through. So I would strongly discourage you from burning a username and password into your application. You really should be using a login method like OAuth, but this is just for demonstration purposes. So the idea is you will connect yourself to your portal, which has got a specific URL, and you'll pass in a credential, and then you will asynchronously load that portal, and you will listen in to when that has changed state. So when you've got a done loading listener, and the first thing you will do is check to see whether that has successfully loaded. So provided everything is well, you can then use the fetch license info method on the portal class, which you listen into asynchronously again, because this is another HTTP call. And when you've finally got that back, you can get the license info from the future, and then that license info can be used inside the set license class of the ArcGIS Runtime environment. Now, this works very well if you're connected to the internet, but we've just been talking about using applications which work offline. So if you then wanted to go ahead and use this application offline, the next thing you have to do, whilst you've got that internet connection, is to save that license info to a string. So I'm just going to convert that to a JSON string, and then I'll have some code that will write that to my disk. Now, when I start my application up, when I don't have any network connectivity, I can use this license info reinflated from JSON to license my app. And these strings work for a period of 30 days. So as long as you can reconnect to your portal every 30 days, it'll work for you. So starting my application up, when I don't have any network connection, I'm going to grab that string from disk, reinflate my license info class using the from_JSON method. And then, as before, I can put that license info into the set license method in my ArcGIS Runtime environment, and that licenses my application whilst I'm offline. So now moving on to deploying your application. So the typical workflow is you use your IDE of choice. IntelliJ is probably the most popular these days, but there's still a good following of people using Eclipse and NetBeans. But the idea is you will write and hopefully very thoroughly test an application that you can compile into a runnable jar. And this runnable jar can then be put onto your deployment platform. So this can be on Windows, Linux, or Mac. And the runnable jar will work inside the Java runtime environment for the platform that you're running it on. But the thing you need to remember here is that we're not talking here about pure Java applications. All the rendering capabilities of runtime are written in C++. So to make this application work in a Windows environment, you need to include the DLL file that comes with the SDK for Windows. Or if you want to make it work on Linux, there's an SO file, and we have a dilib file for macOS. And in fact, if you create yourself a deployment which has got all of these compiled core libraries, you will have an application that will run on any platform that you choose to execute it on. So to demonstrate that, I'm going to hand you back now to Jonathan, who's got a deployment that he made earlier.
Thanks, Mark. So what I've got here is I've created a jar file from the demo we've looked at just previously. And next to it in a folder called JNI libs, if we have a closer look inside, I'm going to have the dynamic libraries for the different platforms that are supported. In my case, I'm on Windows 64-bit. So I'm going to have a look inside, and here are the libraries that I'm going to need to run my jar file on my platform. So let's have a quick look. And as a proof of concept, it will load up just as we had it running from the IDE. And I'll pass you back to Mark to show you how that's going to work on a Mac.
Right. Okay. So I have exactly the same file structure on my Mac, and as you can see here, I've got the jar file. So this is the runnable jar that was compiled on a Windows machine in this case. And the reason this is going to work on my Mac is that I've got the compiled runtime core libraries, the dilib libraries, which will be dynamically loaded inside my Java application. So if I now run this inside my Java app, so I'm just going to do this by the command line, you can see that I've got exactly the same data. So I've got my mountains or my Munros in Scotland that Jonathan has been and climbed all of. That's quite impressive. You can see this does look like a Mac application because the closed windows are on the left here rather than on the right in the Windows application. But this is a good thing. This is designed to look like a native Java application running on a Mac. Okay, so let's just now go and summarize what we've been talking about in this session. So what we've been covering here is telling you how you can go about writing cross-platform Java, JavaFX desktop applications using Java 11. We've introduced you to some of the key classes and the techniques that you'll use for creating your own mapping applications. So we've been looking at maps and map views and the loadable pattern. We've looked at graphics overlays for storing temporary or fast-moving data inside your applications, and how we can optimize the use of the graphics card by using renderers. We've covered very briefly the capabilities of offline maps. If you're more interested in this, then I will repeat that we do have some full sessions on this that cover it in much more detail. And we finished off by talking about licensing and deploying your applications. So hopefully this has given you some good information that will get you going using the Java SDK, and I hope you can now write your own applications. Thank you very much. Hope you enjoyed listening.